Yeah, hello everyone. So today let us discuss one very important question from practice papers of INPHO. So it's an physics Olympiad exam. So just through one question, so like all the concepts of thermodynamics will be cleared. Okay, so let us try to see what is that question and what concepts are involved in solving this question. Okay, so let us directly jump into this question. So here what they are telling, so an insulated cylinder, okay, so it's a like cylindrical vessel, whatever that is there, it's completely insulated. That means no heat can given to the surroundings, and or else like vice versa, it cannot take any heat from the surroundings as well. So I am trying to like underline all the key points over here. So there will be many key points. So the first one is it's an insulator cylinder, okay, fine. And next it's divided into what? It's like divided into three compartments A, B, and C. Piston 1 and 2 are connected by a rigid rod. So this is very very important. So they are connected by a what? Rigid rod. And next what they are telling, and next they are telling that it can slide without any friction. There is no friction. Okay, there is no friction that is involved. So that's also fine. Piston 1 is perfectly conducting. So piston 1 is what? Perfectly conducting. And then piston 2 is what? Perfectly insulating. So piston 1 is perfectly insulating and piston 2 is perfectly insulating. And equal quantity of ideal gas, equal quantity is there. That means number of moles in all the like three compartments is what? Same. And the state in each and every gas initially is what? Same, that is P naught, V naught, T naught. And they're telling adiabatic expansion coefficient is given as what? Gamma equal to 1.5. So that's also fine. And then next, so the compartment B is slowly given heat through a heater H. So they are telling that, so the compartment B, they are slowly giving a heat through a what? By using a heater that you guys can see over here. And the final volume of the compartment C becomes 4V naught by 9. So the final volume in this compartment C, it becomes what? 4V naught by 9. So you guys can see there are like very important like all the concepts of thermodynamics are involved over here. So that's why I have taken up this question, so that all the concepts of this thermodynamics will be clear for you. So the first one is insulated. Already I told you that importance of this one. Okay, no heat can be supplied to the surroundings, or no heat can be taken from the what? Surroundings. That's fine. So we have like remember that point. So just leave. Okay, so it's of no use considering that it cannot give any heat outside, or it cannot take any heat from outside. So that's done. And the second important point is rigid rod. Okay, rigid rod. So by considering the rigid rod part, so here I am writing the first point. Considering it as a rigid rod, which implies the point which you can realize from here is what? Rigid rod means volume of compartment B, volume of compartment B won't change. Volume of compartment B won't change. Sir, why? Because it's a rigid rod. Okay, it's a rigid rod, so obviously this volume cannot be changed. So that's the takeaway from this note point that I have highlighted. Okay, that means that's one more important point that's given in question. Next, so without any friction, that means there is no loss of energy. Okay, no friction means there is no loss of energy because of that friction and all that stuff. Fine. And next, piston 1 is perfectly conducting. Piston 1 is what? Perfectly conducting. So that means piston 1 is perfectly conducting. Piston 1 is perfectly conducting. Okay, sir, if it is perfectly conducting, what is the takeaway that we can get from that point? So the takeaway from that point would be the heat energy will flow between compartments A comma B until the temperatures become equal. Until the temperatures become equal. So till the temperatures become equal, the heat will flow from where? One compartment to other compartment between what? A and B compartments. That's the meaning of like what? Conducting, perfectly conducting means it will be conducting till the time temperature in both the compartment becomes what? Equal. So whichever the compartment has higher temperature, another compartment might have lower temperature. So heat will flow from higher temperature compartment to lower temperature compartment till the temperature becomes what? Equal. Okay, sir. That's also clear. And then next what? Next point they are telling is piston 2 is what? Insulating, perfectly insulating. So piston 2 is perfectly insulating. Sir, piston 2, what is the takeaway from this point that they have given? So takeaway from this point is no heat from C, compartment C, will be flown to where? To the surroundings. No heat from C will be flown. Either from the surroundings it won't flow, or either to this compartment B also it won't flow. That means delta Q for C is 0. Delta Q for compartment C is 0. That means what is the important conclusion here? So therefore it would be what? It will be what process? Compartment C. Already I was able to figure out compartment C is what? Adiabatic process. Compartment C, what process will be followed? Adiabatic process. That's it, done. So one compartment we are able to figure out what will happen. Now they are like supplying some heat. Okay, so they are supplying some heat through a heater. Okay, that heat we need to find. So that final volume here is becoming how much? Final volume in the compartment C is becoming what? 4V0 by 9. Okay, so now, so you guys need to understand. So not only this question, so instead of finding like these things, I'll try to figure out all the like values. That means complete final state. Let us try to like analyze. Sir, what will be the complete final state? See here, the complete final state would be something like this. So what will be the complete final state? It will be something like this. So they gave 4V0 by 9, which will be less than the previous case. See, it's very, very important here. The volume here already I know. What is the volume here? I know 4V0 by 9 is given, right? Let me write the volume here will be what? 4V0 by 9. Volume here will be what? 4V0 by 9. And volume here will be what? V0. So why? Because already I told you, as it is rigid, volume of the B won't change. This is V0. And sir, what is the volume of in the first one? Volume in the first one would be, sum of these two will be like what? 2V0. Total volume should be 3V0, right? So therefore it should be what? 2V0 minus, what will be the value? 2V0 minus 4V0 by 9. So it will be how much? 18 minus 4, 14V0 by 9. That means volume in the leftmost compartment would be what? 14V0 by 9. Okay, sir, I have found the volume. In each and every compartment I got the volume. Done. Fine. Now next what we need to find? Next we need to find let's say pressure. Okay, so pressure, let me call it as P3 over here, let me call it as P2 over here, let me call it as P1 over here. Okay, that means all three pressures I don't know. And next, let me call the temperature to be what? T. But here also the temperature will be what? T. Right? So why? Because already I told you, because it's perfectly conducting, that the heat will flow from here to here till the temperatures become what? Till the temperatures become equal. So that means here also T and here also T. And then here what will be the temperature? Let me take it as T3. That means total how many unknowns we are having now? So total how many unknowns we are having? 1, 2, 3, 4 and 5. Total 5 unknowns we are having. So to solve these 5 unknowns, like we need to have 5 equations, right? But P3 and T3 directly I can find. P3 and T3 I can directly find. Why? Because let's say this is compartment A, compartment B, compartment C. So let me go to compartment C. In compartment C, already I told you it will follow what? Adiabatic process. So that means I can use PV power gamma equal to what? PV power gamma equal to constant. Right? So PV power gamma equal to constant means original pressure is what? Original pressure is V0. Original volume is V0. Power gamma. Gamma is what? 1.5. Okay, it's given, no, gamma is given as 1.5 over here. And final pressure, I don't know, P3. And final volume is what? 4V naught by 9 whole power of 4V naught by 9 whole power of what? 3 by 2. So here also let me just change 3 by 2. 3 by 2. Right? So then V naught power 3 by 2 will get cancelled. Therefore, P3 value I can get it from I can get it from here. P3 equal to P naught divided by V naught power 3 by 2 will be cancelled. So this can be written as what? 2 by 3 whole square. So 2 by 3 whole cube you will be getting. 2 by 3 whole cube. Right? So which is nothing but 27 P naught by 27 P naught by what? 8. 27 P naught by 8 is the P3 value. So I got the P3 value. Right? So then, sir, how to find the temperature T3? Temperature T3 I can replace PV with what? nRT, and I can write TV power gamma minus 1. Or else we know number of moles initial and number of moles final will be same, right? In compartment C. Any compartment number of moles initial and number of moles final must be same. N initial must be equal to what? N final. And PV equal to nRT, right? PV equal to nRT. N initial will be equal to what? N final, number of moles. So PV equal to nRT. So PV by nR. That means P naught V naught by RT. So PV equal to nRT. So N is nothing but PV by RT. So R into original temperature is what? Original temperature is T naught, which is nothing but final pressure. I got it to be what? 27. I got it as 27 P naught by 8, and final volume, it's already given it as what? 4V naught by 9. 4V naught by 9. So am I doing it correct? Just check for the calculations. It's fine only, right? P3 PV power gamma, and then 2 by 3 whole square. Yeah, 2 by 3 whole cube, and 8, 27, fine. So from here, P naught V naught P naught V naught by R into what? R into temperature, new temperature T3. So then from here you guys can see RR will get cancelled, P naught V naught will get cancelled. So therefore the value of T3 would be equal to what? T3 would be equal to what? From here 9 3s are and 4 2s are 3 by 2. So what's the value I got? 3 by 2 T naught. Right? So from here you can see 9 3s and 4 2s. So 3 by 2. So 3 by 2 T naught. So that means, so already out of the 5 variables that I have, so I was able to find the 2 variables. Okay, already I found the 2 variables. What are the 2 variables? P3 I have found and T3 I have found. Okay, and what are the other variables that are left out? So the other variables that are left out is what? P1, P2 and T, right? So, and here one important thing is like whatever the heat that has flown from here to here. And one more important thing I was like forgot to mention over here. When I say rigid rod, that means volume is constant. That means rigid rod indicates what? Let me erase this thing. The rigid rod indicates what? The rigid rod indicates that volume is constant. Volume is constant means what? It's an isochoric process, right? So that means, so I'm going to use the compartment B. Now our compartment C analysis is done, right? Now compartment B. So what is our key point over here, sir? It is what process? Isochoric process. Isochoric process, right? Because volume is constant. And what about C, compartment C? Compartment C I forgot to write here. It will follow what? Adiabatic process, right? So anyway I have written it over here. So compartment C follows what? Adiabatic process, fine. So as it is isochoric process, let me try to find, so I can find the relation between P2 and T, right? Because by considering the number of moles that I can find. But before that, let me write the value of delta Q over here. So delta work done, obviously work done will be as there is no change in volume, work done will be what? Isochoric work done will be 0. Then delta Q will be what? Delta Q is nothing but it will be equal to what? Delta U. right? So here I know that delta work done will be equal to what? 0. That is one takeaway. When delta q equal to 0, therefore what we can write as delta q equal to 0, I can write delta w 0. So therefore delta q is nothing but what? Delta u, from first law of thermodynamics. But delta u, irrespective of process, I know which is nothing but what? ncv what? Delta t, ncv delta t, right? So ncv delta t, so which is nothing but ncv delta t means what? Final minus initial. Final minus initial means final temperature is, let's say, t, and initial temperature is what? T naught. So that means this is the amount of, okay, heat energy that has like what? Flown. Okay, that has like delta q, right? So delta q positive means this much amount of energy, so it has taken, it got this much amount of energy. So delta q negative means what? It is supplied to the what? Surroundings. Okay, it is given to the surroundings. Delta q positive means what? We have given to the system some energy, we have given to the system. How much energy? This much amount of heat energy that B compartment got. Obviously, from where this energy would have got? So from where we would have got this energy? Let us try to analyze the situation A, compartment A also parallelly. Okay, let us try to analyze the compartment A also parallelly. Okay, and yeah, so we are able to find this delta Q. Now in the compartment 1, so can we conclude any other things in the compartment 1? So then delta q, the same amount of energy will be flowing over there. Then I know delta u I know, delta u I know, delta q I know, delta w I know, but delta w, from there can I find anything? No, I cannot find. But actually, sorry, one important thing here, and we are getting an extra amount of heat also from here. So actually we are getting some, let's say, q amount of heat energy from here. In that, some amount of energy is taken by this one, and remaining energy of remaining heat energy would have given to what? This compartment. So I forgot this. So there is a heater which is supplying some amount of, let's say, like q. So in that q, some amount of q will be taken by this one, and some other amount of q will be taken by this one. And how much amount of heat will be taken by this one? This much amount, right? This much amount of heat will be taken by this one, and as I said, the remaining heat energy will be taken by this one. So now, but here there is a problem for us. We need to find what is the value of p1, p2, and t and t. And yeah, so here there is one more important thing that we can get. One more important thing is these two pistons are connected by rod, and this, see, very important point over here, as compartment 1 and compartment A and C. Okay, so these are like separated by two pistons which are connected by a rigid rod. Consider this as a rigid body. Sir, when this rigid body will come to rest? This rigid body will come to rest only when force from this side and force from this side are what? Same. Force from either sides are same, then only it will come to what? Rest, right? So force from either sides are like what? Same. That means pressure must be what? Same, right? So for the rigid system, whatever the system that is there in between the compartments, rigid system of pistons plus rod. Rigid system here is what? Piston plus what? Pistons plus rod. For the rigid system to come to equilibrium, for the rigid system to reach equilibrium, equilibrium means what? Net force equal to 0. So for the net force to be 0, what should happen, sir? For the net force to be 0, therefore pressure in like column 1, that is pressure in like column A must be equal, compartment A must be equal to pressure in compartment C. So therefore P1 equal to P3. That's it, done. That means we are able to find the value of what? We are able to find the value of P1 as well. Okay, so therefore P1 equal to P3 equal to, already I have found the value of P3, right? What's the value of P3 I have got? P3 value I got it as 27 P naught by 8, which is nothing but 27 P naught by 8. Okay, that means now we need to do the analysis of compartment A as well, right? So in compartment A, if you come to the compartment A, So again, initial number of moles must be equal to what? Final number of moles. That means P naught V naught by RT naught, which must be equal to P naught V naught by RT naught, which is not equal, which is equal to P naught, sorry, not P naught, final pressure I have found. What is the final pressure? P1 I got 27, P naught by 8, this is final pressure. Final volume already we have found, right? 14 V naught by 9, 14 V naught by 9 into, sorry, by divided by RT, right? So therefore from here you can see RR will get cancelled, P naught V naught will get cancelled. So therefore what's the value of T we are getting? Therefore the value of T we are getting is, so this is 9 threes, right? This will be how many times? 9 threes and 2 fours, 2 sevens, so 7 threes are 21. So 21T divided by how much? So 21T divided by 7 threes are, 21T divided by T naught divided by 4. So this is the value of T we are getting. This is the value of temperature we are getting, right? So I was able to find the T as well. So once we get the value of T, that means now I know the temperature in compartment. Actually I have found the temperature in compartment A, but once I was able to find the temperature in compartment A, same is the temperature in compartment B as well. Now I know the temperature and I know the volume, so automatically I can find what? Automatically I can find the pressure P2. So how to find the pressure P2 in compartment B? So let me just shift this to compartment A, because this here we are finding pressure in first case, right? Compartment A we are finding the pressure, so I am just shifting it to compartment okay, actually it should be upside down. 1 second, it should be over here. Means because the pressure P1 we have found in compartment what? Compartment A, right? So that's why I am just shifting it over here. First we have found this, then by using that I have found the temperature. Now by using this temperature, now the same thing I'll again do over here, right? Surveyor here also in compartment B also, initial moles equal to what? Final moles. Initial moles P naught V naught by RT naught, which is equal to what is the final pressure that we got? Final pressure that we got is P2, which I don't know, that I need to find. P2 into final volume remains same, into RT, just now we have found, which is nothing but 21T naught by how much? 21T naught by 4. So that means from here you guys can see RR will get cancelled and V naught will get cancelled, T naught will get cancelled. So therefore what's the value of P2 we are getting? P2 is nothing but 21 P naught by 4, 21 P naught by, correct? Yeah, so 21 P naught by 4. So from here you guys can see I was able to find all the unknowns that we had. So what are all the unknowns that we had? You guys can see, first I don't know what is P3 and T3. From compartment 3 I have found what is the P3 value. So P3 value is over here. So where is P3 value? See, here is the P3 value. By using that I also found the value of what? T3. So P3 T3 are done. Next what value I have found? Means I have found the value of P1. Why? Because P1 will be equal to P3. So that is the rigid body system. Net force must be 0. Then I have found P1. After finding P1, as I already know V1, okay, then I have found the value of what? T, by equating the initial number of moles to the final moles. Then after knowing T, and as I already know the volume V naught in the second compartment finally also, from there what we have found? From there I have found the value of P2. So that means now basically I know all the values. Okay, now I know all the unknowns that I had. Now let us see what we can find. I want to find what is in the question they are asking how much amount of heat is supplied, right? In the question what they are asking? In the question they are asking, calculate the heat supplied by the what? Heater. So you need to find the heat supplied by the heater, right? So to find the heat supplied by the heater, delta Q. So what I'll do, so basically I can find, as it is isochoric process, basically I can find what is the amount of Q that is supplied for this one, and I can also find what is the amount of Q that is supplied for this one. Okay, so and to do that, one more important thing is, see, again, it's like, as I said, it's a beautiful question. So here I can find delta q very easily, but here finding delta q is again a problem for us. Again finding delta q is a problem, again a problem for us. So how to find? See, first let me find delta q in b, which is very easy, because delta q in b section, which is nothing but, as it is which process, already I found, right? This is delta q in b compartment only. Let us write this is ncv delta t. So number of moles, whatever, like, did they give number of moles? Any number of moles? Equal quantity of ideal gas they are mentioning, but they haven't given number of moles. I am keeping it as n itself. Ncv. Are they mentioning what type of ideal gas? Did they give any type of? Simply they're telling ideal gas, but they told monoatomic or diatomic or whatever it is. Okay, but from gamma, if you want, you guys can find. Anyway, just keep it aside. Ncv delta t. Delta t is what? T final minus T initial. No, what is T final? I got T final. I got this one, and T initial is what? T naught. So from there, delta Q is nothing but T. T is how much? 21 T naught by 4 minus T naught. So therefore, delta QB I am getting. So heat absorbed by the compartment B is NCV how much? NCV, and from here it is 17 T naught, 17 T naught by what? 17 T naught by 4, right? So from here I can do further simplification, but for doing further simplification to get in terms of P naught V naught, I can use one more important like concept over here. We know gamma is equal to what? Gamma is nothing but Cp by Cv for any ideal gas. So that means Cp. So from here I can write it as what? Again, degrees of freedom. Can I find Cv by R? Yeah. So from here Cp can be written as what? Cp minus Cv equal to R. So Cp can be written as what? Cv plus R by Cv. So therefore gamma equal to 1 plus R by what? R by Cv. So from here R by Cv, what will I get? R by Cv, I will be getting it as gamma minus 1. So which implies Cv is nothing but what? Cv is nothing but R by gamma minus 1. But gamma is 1.5. So as gamma is equal to 1.5, 1.5 minus 1 is what? 0.5. So R by 0.5 is nothing but what? 2. R by 0.5 is nothing but what? 2. So therefore Cv value I got it as what? Cv value I got it as 2R. Cv value I got it as what? 2R. So this is also an important result that we have derived. Right? So Cv value I got it as what? 2R. Fine. So let me just substitute over here. Then further we can simplify it, right? Delta QB equal to N. Cv is nothing but what? 2R. NR 2R into 17 T naught by 4. But NR T naught can be written as what? NR T naught can be written as, this will be cancelled 2 times. NR, therefore delta QB is nothing but NR T naught can be written as what? P naught V naught, because initial condition no P naught V naught T naught. So therefore 17 by 2 P naught V naught. 17 by 2 what? P naught V naught. So this is the final heat. Okay, this is the heat that is absorbed by the compartment B. This is the heat absorbed by the compartment B. So I hope it is clear for everyone. But still our task is not done. Okay, still our task is not done. Why? Because I need to find what is the amount of heat supplied by the heater. So heat supplied by the heater, some heat will be taken by what? This compartment B, and as it is perfectly conducting, this is not conducting, so no heat can flow through like this part, and there is anyway no heat is going through this one. It's an adiabatic process, but the heat that I have given, some heat will be going into the B compartment, some heat will be going into the compartment A. Now I need to find the heat in compartment A, but the difficult part over here is I don't know, like we don't know what is the value of what? We don't know what is the value of what is the process that is happening over here. It's not an isochoric, it's not an isobaric, it's not an adiabatic. Like we cannot conclude like it's like a specific concept, right? So then like basically how can we find how could we tell the value of delta Q? So if it is some kind of process, then I know like I can write, so delta q equal to nc delta t, or from there delta w I can find, delta u irrespective of process it is ncv delta t, from there we can find, right? But I don't know the process, like what process is undergoing in this compartment A, so it will be very difficult for us to find, right? So when it is very difficult for us to find, then we need to look for an alternative way here. Okay, so what is the alternative way here? Can I find work done in this compartment? Yes, we can find work done in this compartment, right? So it is basically like what, adiabatic process, right? So it is an adiabatic process. So adiabatic process, work done can be written as what, so you can, like, anyway, like in adiabatic process, you know the formula for work done, right? PV, what, yeah, I forgot the formula, so like quickly let me derive it. So what is the formula, man? So PV power gamma equal to what, constant, right? So work done is nothing but what, integral PdV. So integral PdV means yeah, why did I forget, nr delta t by 1 minus gamma. Yeah, so the process will be what, nr delta t by 1 minus gamma is the work done, right? Yeah, so that means basically I can find the work done in compartment what, compartment C. Then you guys need to understand, whatever the work that is done by the gas in the C compartment, the opposite work should be done in the compartment A. So why? Because let's say obviously this is getting compressed, right? The C is getting compressed. Sir, how you can tell the C is getting compressed? C is getting compressed because the volume is decreased. That means A is getting expanded. That means like here the work done is positive and here the work done is negative. And here one more very important conclusion that is there, because they are like moving rigidly. So what is one more very important thing? Like magnitude of work done in compartment A must be equal to magnitude of work done in compartment B, or compartment C. So why? Because as I said, at every instant, the force from this side is equal to force from this side. So like whatever the work that is being performed over here, the same work will be performed here, but here it's negative work because it is getting compressed. Negative work is done, like, because the work is done on the what, work on the gas, and here the gas itself is doing the work. So that means volume is expanding. So work done here is what, positive. Work done is positive over here, work done is negative over here, but it should be of same magnitude but opposite signs. So here it is negative work and here it is positive work. This I cannot find directly because I don't know what process it is, but here I can find because it's an adiabatic process. Okay, sir, then what is the work done in C case? So therefore mod of delta WA will be equal to, okay, so basically as I already said, it's nothing but work done in compartment A will be positive, but work done in compartment C will be negative, right? Actually the formula is what, nr delta t by 1 minus gamma, right? But here simply I'll write as it is, we have to multiply it with minus 1. So therefore nr delta t by, I'll write gamma minus 1. Simply done, right? So what is delta t? So therefore work done in compartment A, now you guys can find nr delta t, right? So in compartment C, what is delta t? Final temperature minus initial temperature. Final temperature is this one, initial temperature is T naught. So 3 T naught by 2 minus T naught. So how much you will be getting? T naught by 2. Sir, what will be this value? This will be nothing but T naught by 2. Sir, if this is T naught by 2, gamma 1.5 minus 1 is what? 0.5, which is nothing but 1 by 2. So here I got nr delta t, nr T naught, which is nothing but P naught V naught. Which is nothing but what? P naught V naught. That means work done in compartment A, I got the value as what? Work done in compartment A value I have got. Once I got the work done in compartment A, now what we can find? After I got the work done in compartment A, as I already said, for finding delta U, it doesn't like we don't need what type of process it is undergoing, right? We don't need to know what type of process it is undergoing. That means delta UA you can easily find, right? Delta UA you can easily find. Sir, why? Because it's simply irrespective of the process. I know the formula is nothing but what? NCV delta T. So already delta T part I have found. What is the delta T part? Whatever the delta T that is there in compartment B, the same delta T will be there in what? Compartment A, because initial temperature and final temperatures are same. The delta T already I have found. So therefore delta UA, delta compartment, like Change in internal energy in compartment A is nothing but N into Cv also I have found. Cv is nothing but what? 2R. Cv is nothing but what? 2R into delta T. Delta T is what? 17 T naught by 4. 17 T naught by 4. Then this will be how many times? 2 times. So therefore delta UA is equal to nRT naught can be replaced with what? nRTA can be replaced with nRT naught can be replaced with P naught V naught. So therefore 17 by 2 P naught V naught, 17 by 2 P naught V naught. So this will be the change in internal energy in the compartment what? Compartment A. Now after knowing this easily I can find what? Now I could find what is the delta Q in compartment A by using first law of thermodynamics, that is delta UA plus delta WA. But still we are unable to find what process it is. But after knowing delta Q, if you want to know so you just try that, you can find what is the value of x also. Polytropic process V power x equal to constant will be there, right? So after knowing this delta Q, you could be able to find the value of x also. What will be the x for this polytropic process? Okay. But you need to understand this, we are able to find this delta Q not directly, not by knowing the process, indirectly by calculating delta W from some other constraint, but delta U is irrespective of the process we could able to find, and I am adding these two. So therefore what is the value of delta QA? I am getting delta UA already I got 17 by 2 P naught V naught I got plus delta WA how much I got? P naught V naught. So this is the value of delta QA. Therefore now the heat supplied by the heater, let me call it as H, or let me call it as delta Q total. It's being supplied to what? Some amount of heat is stored in compartment A, some amount is supplied to what? Compartment B. So when I add those two, compartment A and compartment B, 17 by 2 plus 17 by 2 is nothing but what? 17 plus P naught V naught. So the answer is what? So the answer is 18 P naught V naught. So this much amount of heat will be what? This much amount of heat will be supplied by the heater. This is the amount of energy that will be supplied by the what? Heater. Understood, right? So I hope it is pretty much clear for everyone. This is the amount of heat delta Q total that will be supplied by the what? Delta Q total that will be supplied by the heater, right? So I hope it is pretty much clear for you. Okay, so then what they are asking, calculate the amount of heat flown through the piston 1. So it's nothing but what? If they are asking what is the amount of heat flown through the piston 1, it's nothing but what? It's nothing but delta QA only, right? Delta QA is nothing but what? So if you just do like 2, that is 19 P naught V naught by 2 will be the answer. So what will be the answer, sir? 19 P naught V naught by 2 will be the answer for like this one, right? Heat flown through the what? Piston 1. Heat flown through the piston 1. See, after finding these values, as I said, after finding this delta Q in A, you could even find what process it's like the gas, what process the gas in compartment A is following, right? So as you guys can see, the entire thermodynamics, like literally the total thermodynamics is like covered in this single question. So each and every point in this question must be used properly, then only you would be able to get the what answer. For some part we should even use the mechanics constraints here, right? So like the thing, it is not moving and like work done, positive negative work done, literally you need to use mechanics, and literally each and every point of like what is conducting, what is insulating, okay, what is adiabatic process, what is isochoric process, what is first law of thermodynamics, and when gamma is given, how to find CV and how to like conserve the number of moles, and like knowing like delta U is irrespective of the process, how to find delta Q indirectly. Okay, literally we are able to find all these things just within this one single question. All these things are like, all these topics are covered. So that's why, as I said, this is a beautiful question which is from thermodynamics chapter. So basically, as I said, it's like from a physics Olympiad practice questions, INPHO. So just go through this question once again, slowly go through whatever all the points that I told. So literally I tried to cover like this question, like what helped us to cover each and every minute point of the thermodynamics, conservation of moles, like what adiabatic process, like isochoric process. And even if you don't know what type of process, how to find it, and it required some basics of what mechanics over here, right? And then by giving gamma, how to find the value of cv cp, and then also they could ask what is the value of x in the polytropic process, what is the value of x, right? And like knowing what is a conducting, right? Conducting, like perfectly conducting, what does mean, what does it mean by perfectly conducting, what does it mean by perfectly insulating, right? And like when heat is given, like some heat, how the heat is getting distributed, why not the heat is going to the compartment c. So all these things have like covered literally each and every point of thermodynamics is like covered in this question. So that's why repeatedly in like my previous videos also I was like about to do this question. Every video that I'm doing I was telling I'm using about thermodynamics, right? So now I hope you guys understood like how good this question is, right? So I was like in this back of my mind this question is running, that I wanted to do a video on this question because I found it, this is like very beautiful. So as this question is there in my mind every time when I'm talking, I was without my sense I was simply telling that it's like thermodynamics. Okay, so finally anyway I have made a video on thermodynamics. Fine, yeah, thank you, bye bye, enjoy.